Okay, click those all the way closed for me, please, for just a second here. I want to show you how to do this stuff.
Oh.
This stuff, right? So this is the second assignment from 3.1. I want to maybe real quick while we're doing this, let's look at the last couple problems on the previous assignment. They relate to this as well. So something like this. Okay, so this is the end of the first assignment from 3.1. They're asking you to solve an equation, and rather than having to go through and do all the algebra, which we did in the previous unit, I'm giving you a good resource here. It makes this very quick and easy. Notice that I give you a graph, right? So they're asking you to solve the equation f of x equals 2, right? Well, here's f of x. If I were to set that equation equal to 2, which is what this is asking us to do, right? It wants us to know when does f of x equal 2. So I get negative 1/4 x squared plus 5 halves x minus 17/4 equals 2. I would have to just solve that quadratic equation. Okay,
Oh, that's me.
That's for you, yep.
Hello.
Good.
This is over here.
All right, thanks.
That's so awkward.
So, no. So then to solve this, I'd want to clear fractions, right? I mean, we'd have to go through a whole process. We'd have to multiply both sides by 4 to clear the fractions. I'd have to put it in standard form, and then I would just do the stuff that we've been talking about now for a few weeks, right, in Unit 2, where we have to solve the quadratic equation using the best method, whatever that is, right? But we don't have to do that here. Right here, the equation is already, let me make this just a little bit bigger. Notice that the equation is already graphed for us. Right? They graphed f of x in blue. There it is. There's the graph, right? They want to know when is f of x equal to 2. There's a really easy way to do this, right? If I want to know when the blue graph has a value of 2, I could just graph the equation y equals 2, which is a horizontal line at 2, isn't it? Right? See if you can tell me, based on this graph, what the solutions are. So there's the line, f of x equals 2, right there. What do you think? Meaning the point 5.2? Yeah. Okay, so yeah, look at the point of intersection here. Right, the point of intersection where the red line, which is just a graph of the line y equals 2, crosses f of x. They cross at the point with coordinates x equals 5, y equals 2. Now when we solve this equation up here, if I set, well, I had it written down up here, didn't I? It's like that equation right there, right? If I were to solve that equation, what am I solving for? What variable am I solving for there? X, right? So we're just looking for x values. If I'm solving an equation with x's in it, I'm trying to find the values of x that make it true, right? So in this case, what is the one value of x that makes this true? 5. There it is, right? Good, so that's my answer.
Oh my god.
Are you kidding?
I'm not kidding, right?
That's like too great of a math. Even I can do that.
Yeah, if you have, so now you don't always get that option, right? there are gonna be times when you're not gonna have that option because you don't have a graph, you don't have a graphing calculator available, or Desmos, and so you've gotta solve it algebraically, which is what Unit 2 was all about, right? But sometimes, we can take a good shortcut here if we just recognize that relationship, right? We wanna know, when does the blue graph have a y value of 2? Well, just intersect it with a horizontal line at y equals 2 to find those places. It's really easy to do, right? Now, what if, instead of being a 2, that was a 3? Well, what would have happened? Where's the intersection there? Do they intersect?
No.
So what would the solution be this time? No real solutions, right? Because there is no intersection. The real solutions are always going to be the intersections of the two graphs. What if it had said something like, instead, like maybe y equals, -4? So right there, then I would have had two answers. I would have either had x equals 0 or x equals, it looks, I mean, you know, if those happened to cross at convenient places, I can see the intersections, the two intersections this time. I would have gotten 2x values for my solutions, right? Okay, so, which brings us to the next assignment. Okay, in the next assignment, we're doing some things where you can use technology to make the graph or create the function that gets the answer for you, right? So this is stuff where you have, and starting about now, every time we do a unit test, there's going to be a graphing utility part and a non-graphing utility part. The non-graphing utility part is like what we did in Unit 2. That's the algebra that you got to know how to do. But there's also going to be a graphing part of it where you get to use Desmos or a graphing calculator to make these problems really easy, but that's important to know how to do. Those tests are typically going to be, if you just learn how to use the technology, they're really easy, but you got to know how to use the technology. It's important to know that, though, because when you go to college, that's a big part of what you're going to do in your math and science classes. So what about something like this? Now, I still see some Chromebooks opened up. Close those up. I got to show this to you, because you got to know how to do this. So you can get back to them, I promise. Aaron, you got to close yours too. There we go. Thanks. So look what we got here. We've got the situation where we have a model. Company produces widgets. In economics classes, that's just the name we always give to some random product. It represents something, right? The production cost for widgets is given by the polynomial. It's a fancy word, just a function, right? C of x. So if it's C of x, what's the input variable? X. No, x is, right? Whatever's, we're taking C as a function of x. So the x's are what we're inputting, and it's outputting C, which stands for cost, right? There's our cost. So we input x's and it outputs cost, and here's the function we use, right? Well, what does x represent? Where x represents the number of years after 2005. So in this model, we're going to input a year, and the function is going to spit out a production cost, right? So what would we do then if we want to predict the production cost? So we want to know the value of C, right? For the year 2009. What's significant about the year 2009?
It's 4 years after.
4 years after 2005. And so does everybody see that 2009, that is the significance, right? Because X is the number of years after 2005. So that's an X value of what? 4, exactly. All I'm going to do is input a value of 4 into my function. That's it. I just want to know what is C of 4, and that's how we say it in math. C of 4 means the value of the function C when X is equal to 4, right? So all we would have to do then in Desmos is this. So look what I did here. I've already done the work. I just typed into Desmos that function. Everybody see that? So we've got C of x equals 2.4x to the 5th, blah, 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 right? Bunch of stuff. Do notice, though, that in Desmos, like sometimes in Moodle, sometimes I do, sometimes I don't, just to keep track of these big numbers so they're easier to read, I put commas in there, right, for digit groups, around the thousands and the millions and things like that. If I try to do that in Desmos, just be aware of this. Watch what happens if I try to put in a comma there into that big number. it breaks it, right? You can't have commas in big numbers in Desmos. Okay, no commas. Then all I have to do is go down here and just type in C of whatever input value I want. So if I type in C of 10, it's going to give me the value of the production cost at year 10. I want year 4. So if I type in year 4, it gives me right there, it's giving me the output of the function. Okay? So what's that? What is the output of the function here? I've got a little bigger version of this. So the output is when x is 4, which means the year 2009, the cost is 65684.4. It wants us to round to the nearest dollar. So what's that going to be?
65684.
Exactly, right? So we're going to get the answer 65684. It rounds down to the nearest dollar, right? That's it. How simple, right? Okay, next issue. What about problems like that? Well, that looks like the one we just did in the last, from the last assignment that I brought up with the graph. Only they didn't give you a graph this time, but we can make a graph with Desmos. So if we're trying to solve this equation, once again, all I've got to do is let's graph that function in, in some color. Let's make it, what is the color actually? It's, okay, so let me get the colors right here. So this one's going to be in green. And then let's graph this one in purple and look for the intersections. That's all we do in Desmos, right? So I've already got this typed in. So there's the left side, right? Y equals, I'm just going to set the left side, y equals negative 1/4 x squared plus 3x minus 7. There's the right side, y equals minus 1/2, and all I've got to do is look for the intersections of those curves. Well, Desmos will pick those out if I point at them. There they are, right? We've got they intersect at the ordered pair 2.838, negative 1/2, and 9.162, negative 1/2, right? So if I get that a little bigger right here. So what are my solutions going to be? It wants us to round to the nearest 10.
Well, no, that's what I did. Would you put in 0.5x?
Well, no, there's an ordered pair. What's an ordered pair always give you? But it gives you what kinds of values? What value comes first? X, then Y, right? So we're solving for X. So we're going to get one, if I round that to the nearest 10th, that one's 2.8. And this other one is 9.2. How simple, right? And if there's no intersection, there's no solution, so we would just type in the word false.
Would you be able to do it on the graph?
Well, sure, we could solve this. We would just multiply both sides by 4 to clear the fractions, and then put it in standard form and use the quadratic formula or factor or do something like that. You could, sure. Well,
That sounds like six.
that's Unit 2. That's what you did in Unit 2, right? Okay. But you can,
Doesn't mean we like
but-
doing that.
well, you may, well, I wouldn't either. I would rather do it this way, right? It's a lot quicker. So I'm giving you the option on this assignment. That's kind of how I want you to do it. I want you to use the technology because it's quick and it's easy, right? And that's how you do it in real life. Like if your engineer is doing, he's not going to do this all stuff by hand. You're going to put it into a graphing utility and get the answers that way, right? Make sense? Go. Have fun with Desmos. What do you think?
If it's not right,